Okay, so today we will move to chapter 4. Okay, it's about more discussions on pandas. And so the first topic today, oh, I forgot the invitation. The first topic is about grouping and aggregating data. Okay, and this is quite useful. Okay, so just pay attention to this. So for the grouping, it's group values in one or more columns. Okay, and can be distributed across different groups. So it's quite obvious for the concept, and the function that to do grouping. This is a very important function used a lot. Okay, it's called group by. Okay, and for this function, uh, so you can apply it to the data frame. Okay. And for this function, it's going to create some subsets of data. Okay. It's with one or more columns as a group case. So later on, when we take a look at example, we will have better understanding. Okay. But temporarily, just keep in mind this function group by. So it will group values, okay, in one or more columns. And because the data is going to be distributed across different groups, okay, so it can do the grouping. And normally the result that directly returned by group by, we then going to apply some, oh, like over here emphasized, some existing or user-defined operations after you do the group by. So some function like you do the mean for the group, maximum for the group, summation, so and some other functions. So basically, those are the aggregation operations. Okay, so you can apply the aggregation operations then on the subsets. The subsets is you get the subsets from the group by functions. Okay, so that's the concept here. Later on, we will see the example. So first, let's go to today's concept. Okay. And the second concept and example we are going to go over today is about merging, concatenate, and joining multiple data frames together, because that's used a lot in the real world. Okay, you're not just going to deal with single um, a single data frame. So, but there are some conditions is when you wanted to do merge and join, they needed to have some compatible row index or columns, okay, so that they can be combined. And when you do combine, you can specify like combine along which axis. And previously we also learned, okay, axis 0, then it's for rows. Axis 1 is for columns, okay. And there are three functions that will allow us to do that. One is concatenate function. For the concatenate function, so it can stack multiple data frames vertically or horizontally. So it supports you either make the data frame, you combine them vertically, or you combine them horizontally. So make them either longer or wider, okay? So that's the concatenate. And the second is merge function. So merge function is combine multiple data frames based on matching columns. So they need to have some matching columns so that they can be merged together. Okay, so and here also give the index. Later on, when we examine the examples, we can have some better understanding. The third one is join. Okay, so join is combine multiple frames based on matching columns or index. Okay, so it's kind of something like from database join. Oh. So the next major topic is about data frames reshaping. Okay, so it says you can reshape a wide data frame to a long one, or you can reshape a long one to a wide data frame. So there are a couple of functions, okay, but it serves for different purpose, okay. The pivot table, this also used a lot, pivot table. The pivot table is not just a reshape, it also provides some summarization description, okay? So if you want also do some summarization for your data and the reshape, you can pick a pivot table. The second is melt. Melt, it reshapes the data from long to wide format, okay? And there are two other functions called stack and unstack. So this allow data frame reshape with pivoting the levels of their index. Okay, so you can do the stack. So stack basically is kind of you move columns to rows. Okay, for unstack is then you move the rows to columns. So for stack, then definitely you make the data frame from wide to longer, etc. And for unstack, you from longer to wide. Okay. So this just do the reshape. It doesn't provide a summarization, not like a pivot table. Okay. So pivot table also used a lot when you do data analysis, like the group by also used quite often. Okay, and the next topic is about time series. Okay. And for the time series, data is a specialized datetime related objects. Okay, so we will also see that. Here it also give us a couple of functions that we can use. The very first is datetime index. So this can be used to create index for time-based data. Okay. Second is datetime. So datetime is create date time object from datetime module. Okay, and we will see that. The third is date range. So it create a datetime index object with the specified date range. So you can specify, okay. The grouper is used to create some grouper object so that you can do group by, okay. But it's not always you need when you do group by, you always need a group by object. That's not the case. Okay, you can specify some key to do the group by, but there are some other times that you may want to use some group object. Then you can use the group object to do the group by. So this is regarding time series. And the last topic in this chapter that we are going to go over is regarding file input and output. So previously we also discussed, okay, in Python, in chapter 1, we discussed file input output. Then in NumPy, we also discussed file input and output. And for Pandas, it also has um, uh, various functions that can help us do file input and output. Okay, for CSV file, and we already saw some examples. Okay, so if you want to read data, is it to create data frame from CSV, you call the read CSV. It also allow you to write. So you have data frame, you want to save it to CSV, you can also call to CSV. So write data file too. So this is for CSV. Okay. And the next pair is for Excel. So also support Excel. So you can directly read from Excel file or read Excel. You can also write to Excel. And sometimes you also have database. Okay. You can also read data from database directly. So read SQL and write. So to SQL. Okay. So CSV, Excel, and SQL. So all supported. Okay. So that's a general concept for this chapter. So next, let's go to the coding part. So let me do share screen. Okay, so the very first, if you recall, is about grouping and aggregating data. Okay, so let's take a look at example. So here we first have a dictionary regarding stock data. So we have ticker, we have the price, and we have the transaction volume. Okay. Then we use this dictionary to create this data frame. So the data frame looks like this. So it has 3 columns. And for the index part, for the row part, it uses the default, not the labeled ones. Okay. And then over here, if you take a look, because if you examine the data, you will find like you have 2 Apple ticker, is it? You have 3 Tesla ticker, have 1 Google ticker, is it? So is there some way like kind of we can group the results based on the ticker, is it? So that's how you can call the group by function, okay? And so here you pass in the key you want to group by key. So you pass in basically here, that's the column for ticker, as it. So, okay, so it will group by. And if you recall previously, we said normally we just don't like just stop at group by. Okay, normally then you apply some aggregation. And here the aggregation is data frames describe operation or some operation. So here you apply that describe operation. So the describe, if you recall previously, it can give you the data frames general statistic information. Okay. So after we apply this, if we take a look at the result, you can see the result is, so the result is grouped by the ticker, is it? And it gives you the counts, mean value, standard deviation, mean, minimum, maximum, is it? And also there, so this part is for the price. And so this part is for the price. For price. And then for volume, do the same thing. Okay, so that's about the group by, okay, the first use case. Let's see the next one. So the next one, we still use the same stock data, if you recall. We have ticker, we have stock price, and we also have stock transaction volume, okay? And what here we do here is a user-defined function. So what this function does is it return the price columns' mean and also the price columns' maximum value. So it will return two values, okay? Mean and maximum to apply. So then for this one, it still does group by the ticker, okay? Using ticker column as the key. And then if you recall last class, we discussed that apply function, is it? We also have the map, if you recall, okay? And here we do the apply. For this apply, then you apply this user-defined function. Okay, so user-defined function is to calculate the mean and the maximum regarding just the price. So if you take a look at the result, so the result, then it's grouped by individual ticker. As it for each ticker, it gives its mean price and the maximum price. So we can see very useful, because a lot of time for your data analysis, you need to collect this kind of information that then you can use this group by function. And what the next one shows us, you see, not just when you do group by, it's not just support like a single key. It can also support multiple key. So here we are going to do group by two column, ticker column and volume column, okay? And then you're going to pick the price column to do the group by, and group by ticker and the column, okay, for price. After that, you're going to do the summation for the aggregation. So if you take a look at the result, you will see here. We have, so basically for this result is kind of show a uh, multiple index, okay, multi-level index, level index. Okay, because if you take a look here, basically we have two level of index. You have ticker, and under each ticker you can have different volume, is it? And over here we only have one column. So for this data frame, you have one column, but you have multiple level index. Okay. So one is ticker. So ticker is kind of the outer one, and the volume is kind of like the inner one. Okay. So this is the group by result, and it has a multi-level index, or we call it hierarchical. Is it hierarchical? Hierarchical index. Okay, so multiple level of rows. And so this is because a group by using multiple keys. Okay, then the result, after you do aggregation, the result will be the multi-level ones. And later we will see a number of the multi-level index, the hierarchical index. Okay, next, let's see what the next one does. So the next one, similar, it define a user-defined function. So for this user-defined function, if you take a look, so it pick the price column. And here it does filtering, if you recall. Previously, we also learned, okay. It does filtering. So only pick the price greater than 915, okay. So that's what this function does. Okay, still group by this time single column, single key ticker, okay. Then the operation is going to be this user-defined function. So for user-defined function, then you can call the apply and then plug it in, okay. And if you take a look at the result, then it gives us, okay, for each of the tickers that meet this condition, is that it will give you their price and the volume, okay, and the ticker, okay. Here it also shows its index. Okay, then next, let's take a look. So the next one, we do the group by. The first to do group by still ticker, but just based on price. And then you do summation, okay? So that's the result. So the result, we have 3 tickers. So this is the price summation. And what the next one is still regarding price, and you group by ticker, but this time you calculate mean. So this is for the mean. And this is for the sum, okay? And for this one, it's just based on just do the value counts, okay? So that's not the group by things. So it's kind of like a histogram. So the above discuss about the group by, okay, just keep that in mind. Very, very useful function in Pandas. What next we are going to discuss merging and joining multiple data frames, okay, discuss each of the functions. So first, let's take a look the data frame. So over here, we have a two-dimensional NumPy array, okay. Then we have a list, another list. So this list is for ticker, this list is for year. Then we create a data frame using the NumPy array, okay, and specify the two lists as a label, okay. So here we use label for index. We also use label for columns. And then you may ask, what does this do? Okay, so for the row index, sometimes you also want to give it a name. Okay, so then you can just do the index.name. Then for all of the index, it give it a name. And for column, same thing. Then you just say, okay, for all of the column, I gave it the name, the index, a name called the ticker. Okay. And after we do this, you output this newly created data frame. So let's take a quick look what the data frame looks like. So that's what the data frame look like. This is the data frame. Okay, for this data, so that's from the list, the column name for the list. And here is the year also from the list. But if you take a look here, if you recall the year and the ticker, is it? So the year is the index name and the ticker is a column name. Okay, so if you want to set the name for the index of the index and for of the column, then you can do something like this. Okay. So that's the idea. Okay, the next one. So we have 3 series created, and they all have their index. Okay, 3 series. And then we create the data frame using these 3 series. And you basically create a dictionary with the 3 series and using the stock ticker as the key part. Okay. And similar, you assign then the name for both index and the columns. Okay. For this second data frame. So it looks like something like this. Okay. And if we do a more detailed examination, you will find both share the same column, Apple. Okay, for all of the others, they don't share with, so only Apple column, both data frame share. Okay, so we create 2 data frames. Then next, let's see what kind of merge and combine we can do. Okay, so the very first we do is we call the concat, and it's just from the Pandas, okay, package. So you just call PD then concat function. And then over here, if you take a look, you just plug in those 2 data frame and put them in a list. So you put 2 data frame in a list, and then you pass the list to the concat function. Okay. So this will give us some result. So it also does for the newly generated data frame, it also set the index a name and the column a name. So let's take a look what it looks like, okay? Then we will understand the what does the concat function do. So the result, if you take a close look, it will be all of this part. If you recall the previous data frame, the first data frame it has 5 columns, Meta, Amazon, Apple, Microsoft, and Tesla. And for the second one, it has Apple, NVIDIA, and MU, okay? And when you call the concat and just pass in the 2 data frame in a list, so the result will be something like this. So if you take a look at the index, the rows, it repeat. So this, it repeat. And if you take a look at the column, so this 2 new one kind of added to the first data frame is that Apple is already exist. And so it's kind of expand the column. So including all of the column from both data frame and also include all of the rows. But if you take a look, the top part kind of just from the original, the first data frame. So for the first data frame, NVIDIA and MU are not their columns. So that's why over here, both column will be filled with the nav values, okay? And same thing for the second part, for the bottom part, that's from the second data frame. So for the first, for the column that's from the first data frame, then they will also be filled with the nav values, okay? So this is when we do concatenate with this case. Because over here, we just provide you just provide the data frames that you are going to do the concatenation. You didn't specify other stuff. So for all of the other, they just use the default values. So for the default values, then you can see for the column, it will include everyone but filled with the nav values if it doesn't exist in one of the data frame, okay? And it's kind of like do the vertical also, okay? So vertically, so the index also going to be repeated, okay? And then let's take a look at the second concatenate case. So still those two data frame, but this time set the ignore index as true. So what does that mean? Okay, so let's take a look at the result. Let's just set the ignore index as true. And if you take a look, so here is the result. The result look a lot like the previous one. If we take a close look, is it? So it includes all of the columns. And if the column doesn't exist in one of the data frame, it will be filled with the nav values. So that's the same thing, is it? But let's take a look here. The index part. The index part doesn't have the year index, the labeled anymore. It filled with all of the default numbers. Is it? That's because that ignore index is set to true. Okay, so it will not use the original index. It will use the default number ones. So that's if you set up that flag as true, so you will get this kind of result, okay? So that's from the result, ignore index as true, okay? The next one, see, we still pass in the list of those two data frames, okay? But here we also set the keys, okay? So key you provide, you said, okay, first one and the second one, okay? So what does this mean? Oh, let's take a look at the result. If you take a look at the result, this time it looks like this. Kind of similar as the previous result, is it? Still has all of the columns and all of the years, is it? And still filled with the nav values if it doesn't exist. And the year index also repeated. But if you take another look, that the first one and the second one, those come from the key, if you recall, is it? So for this one, it looks like that you have two index, two levels of index. And then you have columns. Okay, so this is similar as what we previously discussed. Okay, so multiple level index. Okay, multi-level index or hierarchical, okay, index. So you have two level. So over here, first one. So under first one, then you have this 4 year. Under second one, you also have this 4 year index, is it? So this is multiple level index. So if you want to have some result that looks like this, then you can also set up the keys. Then you will achieve the result that looks like this. So this is regarding the key argument if you want to do something on it. And what is the next? Let's take a look. So still do concat, but this time for the join argument, you specify as inner. Okay, if you take a look, then we have the next. You can also set up as outer. Okay, so this is some concept, kind of like from database. Okay, outer join or inner join. Is it? So outer, then what it means is a union. Union, so everyone is included. Okay, include everything. Okay, inner, inner will only look for intersection. Not this intersection. It's inter. Um, so only when they shared the same. Okay, intersection. Okay. So that's for the inner join. Okay, so intersection. So it's a common ones. Okay, only the common ones will be included. Okay, common, like if they have the common column. Okay, and for the union, it's not. So by default, if you don't specify, if you take a look like the first case, is it by default, it's outer join. Okay. So if you do want to inner, then you need to specify it's inner join. Okay. So let's take a look for this inner join, what the result looks like. If you take a look, the result is, and if you recall previously, we said for both data frame, they share the same Apple column, is it? So that's how, when they do inner join, they will only keep the common column one. So the Apple is the only one that's in both data frames. So that's the common column. So that's why here for the inner one, it will only find this. So this is the intersection. Intersection. Yeah. So it look for the common ones. Okay. So that's what the inner join does. And then next, let's take a look. Okay, for concatenate, you can also specify the axis. Okay, so axis, you do the concatenate by column or by rows. Okay, along column or along rows. So previously, what we specified, we didn't specify axis is 0. So that's the default one. So it's a long row. So that's why you see the year it's got repeated, is it? So it's also kind of like a vertical stacking, kind of. Okay. And when we concatenate along column, then it's horizontal stacking. Okay, so then axis is 1. So let's take a look. Okay. What the result looks like. It's still those two data frame. But this time we specify the concatenate using axis is 1. So along column. Okay. So if you take a look at the result, that's the first one, the result. Didn't specify the join using the default. Using default, its join is outer join. Okay. So outer join is default. So if we take a look at the result, if you see it will, so this part, the left part is the first data frame, and the right part is the second data frame. So over here, you will see because they share the same index, the same row, is it? So it will just add the new column to the first data frame, okay? And for Apple, it's just repeated, okay? And for the second one, the next one, for the concatenate, this part is exact same. It's just you specify the join as outer join, okay? By default, we also say it's join as outer, but if you specify, and we can also take a look at the result. Basically, the result is no different from the previous one. No. So if you compare so this is a result. Compare with the there is no difference, okay? So that's about concatenate. Next, let's take a look. Oh, so this part is exactly the same as what we previously discussed. Is we just create those two data frame, okay? And before we move to merge, there are a couple of other things and function that's quite useful, okay, when you do data frame manipulation. One is called reset index. Okay, for over here, you see, if we call this stock price, reset index, the output, if you take a look, did you see now the year part got moved to as a column. Previously, it's index, is it? Now the index, they use the default ones. Yeah. So reset index is going to kind of like transfer index to column. Okay, and then use the default index as the index. So similar for the second one, if you take a look, it's also the same thing, okay? Because sometimes when we do some operations, we may need this. So that's why over here, we do this first. And what next it does, so we just converted, is it? So the year will be the column, is it? And a lot of time, if you don't have the name for because for this case, our previous data frame, we set, if you recall, we set the index dot name, is it? And we set it to year. We specifically do that. If you don't have that statement, then over here, it's not going to be year, it's going to be index. Then sometimes you may want to change the column name. So if you want to change column name, so rename function will do that. And then you provide the columns that you want to change the name. So you provide the original, and this is going to be the new name. And in our case, it's the same as the because we already renamed it. Okay, but anyway, so here the rename purpose, it's also quite a practical use. So we change the okay, we change the original data frame is that we change the year index to as one of the columns. Okay, and over here we do this. If you recall previously, we have the columns dot name, and we set it to as a ticker, if you recall. Previously, we did that, is it? And now we want to remove it as a column index name. So you can set it as none, okay? So then the result doesn't have that ticker here because that doesn't make sense. Here you also have year as column. So that's why we want to remove it. Then you can do something like this, okay? Then let's see the result. What does the result look like? Then the result looks something like this. So that's the first data frame. You rearranged it. Now year is one of the column, and the index is just the numeric number. Same thing for the second one, okay? After this, let's see what we did. And here, same thing, okay, you rename it, okay? And then we call the merge function this time, okay? And this time, for the merge, there are two ways to use. You can do the PD merge, then you pass in both data frame. You can also call the merge on one of the data frame, okay, because merge also belongs to the data frame. So in this case, the first data frame, then you call its merge function, then you pass in the second data frame, okay. And here also specify how you want to do the merge on left or merge on right, something like that. And also, if you are going to keep all of the index from both data frames, okay, so we set as both true. So what here left, you set how as left, that means this data frame. So the function, the merge function belongs to. So this is the left. So this we consider as a left data frame. And this we consider as right data frame. Okay, so for this left data frame, then all of its columns will be kept. Okay, so all rows and so all of the rows from that one, they will be kept. Okay, and the right data frame, so only matching rows which have the same index, then they will be kept. Okay, it says for rows that doesn't have matching index, then the net value will be filled with the respective columns. So that's what this merge does. Okay, so we take a look at the result that can help us understand better. So that's what the result looks like. So this is merge on the left, okay? merge on the left, if you take a look over here, the year, it will be capped, okay? And it has the X and Y. So this suffix, okay? So the X is for the left and the Y is for the right. And for the apple, because both data frame have the same column of year and the same column of apple, and how do we differentiate? If you recall, that's because we set the left index as true and the right index as true, is it? That's why you want to keep that. So over here, that's why you have this underscore X and underscore Y, okay? And based on, for the merge, it's based on if the left on the index, if the right one has the same one as the left one for the index. If it has, then all of that will be, the rows will be kept. If it doesn't have that, then it will be filled with none. Okay, so that's what the concept is here. And then next, let's take a look at the second case for the merge. So now for the second, it does that merge left and right. Didn't specify a lot. It just didn't specify how. It just specify on which column you are going to do the merge. If you recall previously on the slides, we said merge is not like concat. Okay, merge will only use the column to do the merging and the join, okay, not like a concat. So if we do the specify a column to do the merge, then let's see the result. So the result, if we take a look this time, because it's specify you're going to merge on year, is it? So that's why this time for the year column, you will only have one. You're not going to have two. But for the apple, the same column, is it on both data frame? So it will still have the suffix, okay, X and Y for left and for right. So this is about merge. And next, let's see. So this part is the same as what we previously did. Okay, we try to have those two data frame. Okay, and oh, this time. So for this part, it's the same. So we have this first data frame, and we have the second data frame we haven't created, but we create three different series, okay? And this time what we do is we first convert those three series into data frames, okay? And because we want to do join, okay? So for this join, if you take a look, this is the first series. Basically, you already converted to data frame. Then you call the join, okay, from this data frame. Then you apply the second data frame, okay? And you specify how, okay? So because how is the outer, so it will include everyone, okay? If you take a close look of the first two, they don't have the same, the same index. It is here, you have 2010. Here you don't have the 2010. And for the, you're missing the 2015. And here you have the 2015, is it? But when they join together, they will have all this 4 year. Okay. If certain value is missing, they are just going to supply it with the net value. That's how it works. Okay. And then you join the third one also as outer. And after that, you have this newly formed data frame and you join it to the first one. And this time also specify as outer. So outer is a union including everything. And if the matching index doesn't exist, then you just fill it with the net value. Okay. So if you take a look, that's the result. This is the result. Okay, and from the result, if you take a look, you see that's the net values from the original. Okay, and here you have the index. Okay, so this is join. And let's take a look. We can also do join using the previous. So here, if you recall, these are the two data frames that we at the beginning of the merging and join discussion. Okay, and for this one, this kind of you can write in a short, not multiple statement, just in one statement, you can do everything. Okay, so for this data frame, you can also do set index. Okay, and then you call the join. So then you have the new data frame. Then you call join. Same thing here. You set the second data frame's year as a column. Okay, and then over here you said, okay, for the how, I'm going to do the left join. Okay, and you also provide the suffix for the left data frame and the right data frame. And we also specify here, we are not going to do the sorting. Okay, so what this left is similar. Okay, so you are going to keep all of the columns and rows from the left data frame. And for the right one, and because we, for the right one, if it doesn't exist, then you are going to fill it with net values. So let's take a look at the result. Okay. So this is the result. And if you take a look for the common column, is it when it does the join, then it automatically add what you specified, okay, for the suffixes, okay. And because they share the same index, so everything is included. Okay, so here we got the idea how to merge multiple data frames together. Next, let's take a look at the reshaping, okay, with pivot table, melt, stack, and unstack. And pivot table can also do summarization. So first, let's take a look. So first, we create the data frame using the dictionary, okay? And what this data frame look like. So let's take a look how it looks like. So that's the data frame, okay? So it have multiple years, and the year also have some repetitive. Is it for the ticker also have some repetitive, and the price and the volume, okay? So that's the data frame. And now you call the pivot table on this data frame. And you're going to calculate the value, so you specify the column. So basically, in this case, these two columns are the two columns that have numbers, okay? And you also specify the index and the column, okay? So here you have index and column. Then you said what I'm going to do with the summarization, the subset of the pivot table. I wanted to do the mean. Okay, so this also kind of also have some kind of idea like the group by, okay, but it's not the group by, okay. So it's going to do some summarization, okay, and reshape your data frame. So after we do this pivot table, then let's take a look what the result looks like. So if you take a look at the result, okay, so it will calculate the price and the volume, is it? And based on this two ticker and the number of year. Okay, and here all of these values are not the original. They are the mean values. Okay, so the aggregation results. So it will do a lot of automatic calculation for you in this case. Okay, quite neat. And next, let's see. So still we have that data. Is it this time do the pivot table? Okay, still based on price and volume and the index is the year and the ticker. And this time for the aggregation function, just not the single one. So you can also provide multiple functions. So we do mean, we're also going to do summation, and you can provide them. And if you also provide a name for the output, then you can provide them in a dictionary, okay? And then you see the result, and that, so it will give you the, so this is, uh, so you have the price. So this is for mean, and this is for sum. Okay, so for different column, you can specify different aggregation function, okay? And then it will do the summarization. And the result, again, this time, if you take a look, it has multi-level index this time. So the outer one is year, the inner one is the ticker, okay? So you can see the pivot table is quite convenient, is that if you want to have some summarization result. And what the next one? It's about another pivot table, so still on price and volume, and you specify index here. And this time, the aggregation still the summation, but it also sets another argument margins is true. So what is this? Okay. If you take a look, it will also provide you with some subtotal. Okay. So this time, you see, for the price part, it has it. And it has a new column, all. It also has a new row called all. So this all, this is that margin. Okay, margin. So it will do kind of summation. Okay, it will sum of the rows, sum of the columns. Okay, so if you want to have some results like this, then you can provide, you set up margin as true, okay? And next, let's take a look. So the previous is pivot table, the next is melt. So what does that mean, okay? So this time we are only going to work on that original data. Is it original data? And let's take a look. Review what that data frame look like. Okay, so data by year. Yeah, so something looks like this if you take a look. So it's index not labeled. Okay, it's use number. Okay, and it has a year, ticker, price, and volume. And then let's see, what does this melt do? Okay. So for this melt, it apply to that data frame, and it specify the variables ID. Okay, you're going to use the year and the ticker, and also the value variables you also provide. Okay, so the price and the volume. So those are the numbers. Okay. Then you also provide a variable name. Okay, the value name. And then after we do that, if you take a look at the result, so the result compared with the original data frame is much longer, is it? So if you take a look, it kind of convert all of the uh, column, is it, into rows, is it? Yeah, like the price and the volume, is it? It convert them to rows. So for each one of it, it has provide a number. Okay, so this is regarding the variable like the name. Okay, and the value name. Okay, and here it's based on the values. So the value is the price and the volume. So you see, price and the volume, they are in the same now, just all call it the number column. Okay. So it's kind of not that descriptive now for this data frame. It's just a longer format. But sometimes you may want to have something looks like that, then you can call melt, okay? And what is the next one still on that data? This time you just specify the ID variables, okay? So it's the year and the ticker, okay? And don't specify other things, then it will use the default. So these two are the default, okay, variable and the value. Otherwise, in the previous example, it specifies the name. So this is some trivial difference. So this is regarding melt. Okay, and the next, let's take a look at the other pair of reshaping function, okay? So this time, first, let's take a look at what is a data frame looks like, okay? So you create a data frame and then you set an index. So this time when you do the set index, you pass in a list. So you have two index, ticker and year. So that's how the result looks like. But if we take another close look, you will find you have ticker, then you have year. Okay, so this is also multi-level index. You have two level, ticker as outer and year as inner. Okay, so hierarchical. Okay, hierarchical indexing. Okay. And then with this, you say, okay, I call stack. Okay, so what does this mean? Let's take a look at the result. Then you will see it makes a lot of sense. Okay, for this is the original one, is it? Then you call stack. After you call stack, did you see previously you have this two column? Now after you call the stack, did you see you only have one column? Okay, and both the price and the volume, they converted to index. So now basically over here, you have three level of index. So stack basically will make your data frame longer, okay? So it convert the columns into rows, basically. And you may ask, yeah, can you also convert index to column? Yeah, you can also, then you call unstack, okay? Yeah, do you see if we call unstack on that, then the index got moved back to column, okay? But here we don't specify the level. You can also pass in argument of the level. Yeah, for this one, this time, for that data, you say, okay, level 0. Level 0, if you take a look, then the result is it gets the most outer index to column. Okay, so level 0, that's the outermost one, outermost index to column. Okay, and if level is 1, then it's the innermost index to column. By default, okay, it's also the innermost. So innermost convert to column. Okay. And same thing for stack. Okay. If you have a multiple level of column, then you can also specify which level you want to do the stack. So this is reshaping. And what next concept is about time series. Okay. And so the first one is a date range. You can specify the starting date, the ending, and the frequency over here is set hourly. Okay. And then with this, you can create a data frame. Okay. And for this data frame, then we also add a new column called number, and we use some random number to fill this column. Okay. And for this newly created data frame, you see, okay, I want to use the daytime be the index. So that's what it looks like. Okay. So you can set the daytime. Previously it's column, is it? Now you set it as index. Previous we also learned reset index. Is a reset index is to get the index to column. Okay, you can also set column to index. Okay, so just kind of like a stack and say it's a pair. Okay, you do one operation, you can also reverse it back. Okay, and what next one? Try to show. We already know you can download data frame from Yahoo Finance. Okay, so here we specify start and ending, and you can write the data to a CSV file. So here we just save it as a CSV file. Okay. And then we want to get the data to a data frame. And you set the date as the index, okay, as the index. And then what we also going to do is, because originally this is just a string, okay, and you want to set the date as date time, so you can convert it, call this to date time. So then the index type is going to be datetime index, and you can check. So you can call the type function to check, and the output is that, okay, it is datetime index, okay. So you can do that, and then we can get what this data frame looks like. So now you see it looks like, so the date, so this, the index type is datetime index, okay? Because for time series, a lot of time, if you just use string, when you do processing, it may not be convenient. But if you convert it to datetime index, when you do some processing, it's going to be convenient, okay? That's why sometimes we want to do this kind of conversion. And with the daytime, okay, oh, I got something wrong. Then you can use the dot lock to do the indexing and the slicing. You can just specify, okay, the date range. So that's a pretty straightforward. And you can also do slicing. And with the daytime index, is it then you can also resample. So here is a previous is hourly. Now you said I want to do a weekly, is it? And because you do weekly, then you need to pick either mean or sum or something aggregations. You said, okay, I'm going to pick the maximum value, is it? And then you can get a new data frame, something looks like this. And the next, let's see. So now there's another function. A lot of time when you deal with time series, you also want to do something like this for the calculation. So what we are going to do is regarding that data frame's closing price, that specific column, we are going to do the shifting to, okay, shifting by 2 time periods. Okay, if you take a look at the result, what it looks like. And this is going to be added as a new column, okay? So then did you see for the new column? This is a new column based on close price. Is it because it's a shift to, okay, so it's a push down 2 day. So the first 2 day, there is no value. So that's why I filled with net. And then the first one got moved to the third. Okay, so that's what this shift does. Okay, so sometimes for time series, quite useful. And you wanted to know the price difference, then you can just does the calculation based on this shifted price, is it? So just do subtraction. Then it will be easy to do that. But of course, if you have the net value, then it will be still net value. But this is a new column, is it? It will, based on this close and the shifted, and it will find the difference. So it's easy to do the calculation. And there is another function, sometimes also used with time series, is the rolling, okay? And you specify the windows. So what this does is rolling windows used for calculating statistics over a fixed period of time, window of time. So it's used for calculation, the statistic, okay? So over here, window 3 says you want to calculate the rollings over a window of 3 days. So what that means is for each day, it will consider the closing price of that day and the previous 2 days. So rolling 3 days. And you're going to do some statistics. So here it says, okay, I want to find the mean values. Okay. So what over here is trying to show is just to try to show some very, very basic operation when you deal with time series. Okay, this is a very, very basic ones. So over here, you see, you add a new column, rolling mean, okay? So it's based on the previous 2 days, and then it can find the mean value using the closing price here. So that's what this function. So here just shows us some operation applied to time series. And if you recall previously, we learned the group by. At that time when we do group by, we provide some key, okay? Generally speaking, it's some column, okay? And this time, for this data, you say, okay, I want to group by. You can specify some because that column doesn't exist. You specify what you want to do the group by. Here it says, okay, I want to do some group by with the frequency monthly. Okay, then apply the mean value. Then if you take a look, yeah, it basically does the monthly calculation for the mean value for all of those columns. Okay. So this is also because of the time series, okay? Then you can do this. Okay, then next, what to try to show. So we still get the data frame from Yahoo Finance, okay? Specify the ticker and the starting ending date. And this time you write the file to an Excel sheet. Yeah, you can also do this, save it to an Excel sheet. And then you can also read data from Excel sheet, okay? And then build a data frame. And then you can specify which column you want it to be the index, okay? If you want a multi-level index, then you can provide a list. And you can also convert the index to date time index. And then provide the header. So similar operation as the CSV one. Just try to show here, you can also do it using Excel. Okay. And here is the last part is we can also use database, read and write to database. So still same thing, you download. And over here, we didn't do some complicated database, just a very, very simple database engine is called SQLite engine. Okay, SQLite engine. And for other data, you can also do that, okay? And you can check the Pandas documentation. So very first thing is we create a database, okay? And after you create this database table, then you can write the data frame. So this is a data frame. You can write it to the database, and then you specify, okay, with the Tesla, okay, and write to this engine. And if it's the database already exists, if it already exists, you use the new one and set index as true, okay. And because this is a database, and then you can also use SQL language to do operation with your data frame, okay? So then in this case, you want to select specified fields. In database, we call it a field. So this is a database. Okay, this is a table, basically. Database table. Here it means you want to select all fields, or you can specify. You say, okay, I just want to select a closing price or open price. Okay, then you can say, here, if you use a star, that means you select all of the fields, open, high, low, close, all of the fields. They call field. So this is a SQL query language, okay? SQL query statement. So you can write a SQL query statement, and then you call the read SQL and provide the query language and the SQL engine, okay? And then it will create the data frame also for you, okay? So here just shows another, because in the real world, we use database also a lot, okay, not just a CSV, okay? So here just shows multiple ways that you can handle data frame, you can read and write, okay? So that's all of the information regarding chapter 4. So we also completed chapter 4.